So last time we drew a process, we made a PV diagram, pressure volume diagram, and we had an ideal gas go from some V1 to some V2, which is smaller. So we started here and we had some P1, and then we ended up with a higher pressure because the ideal gas law needs to be satisfied. So we end up with a P2 at V1, and we argue that the area under the curve represents the work. Now let's be a little more specific. So we're going that way. The area under the curve, just like the work can be positive or negative, or zero for that matter, but it can be positive or negative depending on whether the displacement is opposite the direction of the force or in the same direction. So the same thing is true here. So it turns out that the work done on the gas is minus the area, right? In some sense, that's a convention. and positive, so it can be positive or negative, depending on the volume, the change in the volume. So let's also notice that here's one way to go from volume 1 to volume 2. And and given this idea that it's the area on the curve that matters, let's think about the area under the curve for the following situation. So let's start with V1. We want to end up at V2. We'll start with P1, just like we did there. We'll end up at the same place. So, but we'll come to V2 at constant pressure, and then we'll go up to P2. Okay, so we'll go that way. What's the area under the curve? Well, it's all of this. And clearly that value is different from this. Let's imagine a different way. We could go up this way and over. So we start with a P1. We want to end up at a P2. Start at V1. We want to end up at a V2. And so now we're going this way. And then we'll decrease the volume to V2. Like that, and so the area under the curve, in this case, is this. Okay, so we notice that the work is path dependent, so the work is path dependent. Okay, so if we remember, we talked about the work, which, of course, by definition is in physics 1, the mechanical, we were dealing with mechanical energies. We defined this quantity, the integral of the force over the distance. And for conservative forces, we found that this was path independent. So this is path independent for conservative forces, right? Like gravity. This holds for electric forces as well. So, but it doesn't hold for friction, right? Not for friction, where friction, the work done is path dependent. And so what we see here is that we're dealing with a gas. The forces that are acting on the system are more like friction forces, not like conservative forces. And that idea is really behind the laws that we are about to generate, the first and second law of thermodynamics.